All right, everyone. Sorry I was a little bit late to recording tonight. That's the joys of having children. We had one that had a little trouble going to sleep tonight, but it was only about 2 minutes late, so that's not too bad. If you are in attendance in this stream and wanted to type something quick in the chat, that would be awesome. Just let me know that you are there. Once I see that there's a few people, looks like we got people here. Okay, we got people here. All right, so we're ready to go. So if we're watching this afterwards, again, all I'm going to do is go through the test review problems. Now, I'm not going to do all of these because there are kind of a ridiculous number of them. So, I mean, looking at it, there's 4 that are in standard form, 4 that are in slope-intercept form, 4 that are in point-slope form, and then 4 where you have to write the equation. I'm not going to go through all of those on review 2, especially because the answers are already there, but I'll probably go through 1, maybe 2 of each of the graphing ones. I might throw in one of my own examples, and then we'll definitely go through all of the equation writing ones, just because I know that for most people that is one of the trickier parts. Okay, so the first one we're going to go through is, I'm going to pick number 2 on there actually. So that is 3x minus 2y equals 4. And I really like starting off with one in standard form, and the reason is really pretty simple. Wait, is Jason on there? Why is Jason on there? Huh, okay. Anywho's, 3x minus 2y equals 4. The reason I like starting off with this kind of problem is a really simple reason. It gets us down back to kind of where graphing comes from, right? And in the end, all graphing is, it's a visual representation of all of the different solutions, okay? So basically, you could convert this into slope-intercept form, and that would work, but my suggestion is just find some solutions that work, okay? So find an x value and a y value that when you plug them in, make the equation true, okay? So one that I found is x equals 0, y equals -2. It's got to be negative, so we get that positive 4. We could also do, looks like x equals 2 and y equals 1. And we could also do x equals 4, y equals 3. Wait, did I do that right? That'd be 12 minus 6. X equals 4, y equals 4. 12 minus 8. So then all I would do is I would plot each of those points as if they were an ordered pair. So 0, -2 is right there. 2, 1 is right there. Oops. And 4, 4 is right there. Okay. And that's really about it. We would connect those with a line. That's a pretty good line. You should ideally put arrows on the end of there too, just to show that it is going on indefinitely. But other than that, that looks pretty great. Okay, so really all we're doing is finding solutions. Now, just for the sake of argument, let's say you wanted to transfer that into slope-intercept form. That's what we're going to be doing next anyway. All you would really do is solve for y. Okay, so you would subtract 3x from both sides. And that would get you -2y equals -3x plus 4. Notice how I'm putting the x value first. That's just because our typical slope-intercept form is y equals mx plus b, so I feel like that just makes the most sense. Okay. Then I would divide everything by -2. And what's awesome here is, for this particular example anyway, I would get y equals -3 over -2. I'm going to leave a fraction, but I'm going to change it to positive. And that positive 4 divides to -2. Okay, so what was cool on this one is that I ended up with a whole number y intercept. And if you look, this leads us straight into slope-intercept form. Our y-intercept would be, let's see if I can find a color I haven't used. Gray will work. There's our y-intercept, right? And then from there, I went up 3 over 2, up 3 over 2. It's a positive slope. It's my rise over my run. It's my change in y over my change in x. Works the exact same way. Now, I wouldn't recommend for equations in standard form, at least not all of them, I would not necessarily recommend converting into slope-intercept form for a couple reasons. One, I actually think there's a larger, I don't know, I feel like there's a slightly larger margin for error there. And number two, if that last digit there, so in this case our 4 that I've just circled, doesn't divide by our -2 that we eventually have to divide by when we're getting y by itself, then you kind of have a problem in that you can't really plot it accurately. Okay, so most of the time it's probably easier for standard form just to find solutions, but if you're finding yourself a little stuck or just want another way to check your answer, you can convert into slope-intercept form. Speaking of which, we're going to now tackle one in slope-intercept form. So looking at your review, which I got to pull up on a separate screen here, let's take a look at, we're going to take a look at number 7, which reads y equals -1/5 x minus 3. So the biggest thing to remember about both point slope form and slope intercept form is that all you really need is you need the slope and you need a place to start, okay? Because the slope just tells you kind of how one point progresses to another point progresses to another point. So you just need a single place to start. Technically, it doesn't matter. Okay, technically you could find any x and y value that make the equation true and then just use the slope to create more points. However, in this case, slope-intercept form and in point-slope form, you've got a very specific one that's pretty easy, okay? This one, your hint is that it's called slope-intercept form, okay? So the y-intercept is the one that's really easy to find. And you find the y-intercept by plugging in 0 for x, okay? So if you plug in 0 for x into this equation, you get y equals 3. So we get a solution of 0, -3. So in the end, that last number in y equals mx plus b is always going to be your y-intercept. So we'll start there and we'll plot there first. Okay. Then, in order to use your slope, for positive slopes, you need to do either 2 positive things or 2 negative things. Okay, and that has to do with the fact that dividing 2 positives or dividing 2 negatives both get you a positive. Here we have a negative slope. Okay, so we have 2 choices. We can either go up 1 and left 5, okay, because that would be moving in the positive y direction, but the negative x direction. Positive divided by a negative is a negative. Or we could do the exact opposite of that. We could go down 1 and we could go right 5. I'm going to do both because you know what, I can. So for my first point, I'm going to go up 1 and over 5. Over to the left 5, I almost went the wrong way. That puts me right here. For my second point, I'm going to go down 1 and right 5. And if you'll notice, they definitely create the exact same slope from that original point. Okay. If it was a positive slope, you would just want to make sure it's trending the other direction. One thing that would probably help most of you to understand is that negative slopes, if you read them from left to right, are going to go downhill, and positive slopes are going to be uphill. Okay, so the one thing I would go back through is on any problem where you have a slope, if it was positive, make sure left to right you're going uphill. If it was negative, make sure left to right you were going downhill. That'd be an easy thing to check over. Okay. Alex asked a fair question. Do we need to show, he said, both slopes? I'm assuming you meant kind of both directions. No, not at all. I mean, especially for ones in point slope form or slope intercept form, you don't even need 3 points. You can just draw 2 points and you can be all done. Okay. Things that get weird in slope intercept form, and a lot of these things came up on one of our review assignments, came up during class a lot. But In the end, there weren't a ton on this particular one, so I just want to make sure we're aware of a couple things. One, if you have, let's tackle two problems at the same time. Let's say y equals 3x. That is technically slope-intercept form, okay? Hang on a second. I'm getting some questions, and I'm going to move my face up to the top of the screen so I can see the new ones coming in. This is two problems on this red one, and then I'll get to those questions. Problem number one is we don't have a plus b, okay? Again, this is why I just stress you just need to find a starting place. So if you're not sure what to do with the missing b and you're not sure, just find a starting point, okay? But if you remember that it's the y-intercept, plug in 0 for x. Well, you see that you also get 0 for y, so it's as if there's a plus 0 at the end. So our starting point is going to be the origin. The other thing is if we have a whole number slope, okay? If we have a whole number slope, we're going to put that over 1. Okay, so in this case, we're going to rise 3, and we're going to run 1. So I'd go up 3 over 1, or I could go down and left 1, because that would amount to the exact same thing. Okay, so that'd be my line. Connect it as best I can. I'm going to give myself credit for that one. That one wasn't too bad. Okay, so that's definitely one of the problems that can come up in slope-intercept form. Talia asked, do you care what method we use? Honestly, not really. In the end, like even for y equals -1/5 x minus 3, you could just find a set of values, and that would totally be fine, okay? So I feel like you should be practiced with all methods. You should be able to do it by making a table, because converting to slope-intercept form isn't always possible. And you should typically be able to use slope-intercept and what we're going to look at next, which is point-slope form. You really should be able to use those just because they're significantly faster. But in the end, as long as you create an accurate graph, that works for me, okay? So moving on. Oh, that one. There we go. We're going to look now at point-slope form. Let's look at, number 9. Actually, that first one that comes up looks really pretty awesome to me. So that's y plus 2 equals, don't mind me, I'm going to skip to the next line, 3/4 x minus 1. Again, you just need a place to start, and then you can use that slope of 3 over 4. The easiest place to start in point slope form is you find the x and y value that make both sides 0. So in this case, x equals 1, y equals -2 would make both sides 0. The reason that works awesome is due to the parentheses around x minus 1. If you plug in 1 for x, you get 0, and then it doesn't matter what your slope is. In this case, it was 3/4, but it could have been any number. It was going to multiply to be 0 due to the order of operations, okay? Again, you could have found any point here, but this is one of these prime examples where you're not going to be able to convert to slope-intercept form in any real easy way, because distributing that through, you would get a fraction, okay? And we don't want to deal with a fraction y-intercept because it doesn't allow us to graph as accurately, okay? So we're going to graph the point 1, -2, which is right here, and then we're going to go up 3 over 4, which is right there. We'll connect them with a line, and we'll be all done. Okay, so that's point slope form. Now, point slope form ends up, I think, being really, really important when we talk about writing equations of lines, okay? So the whole next section on that review is about writing equations of lines given information. So in each of these cases, you're given something a little bit different. Okay, in the first one, you're given a slope of -1/5. Now I'm going to use m for slope because that's what we typically use, okay? Now I don't want to write the word slope over and over again. And you're given a y-intercept of -3. In the second one, you're given that it goes through the point -3, -4. That's a solution. That's a point on the graph. And that it has a slope of 2. In the next one, you're given that it goes through 2 very specific points. And in the last one, which is a lot easier than it looks, I think, you're given that it goes through a very specific point, and that it is parallel to y equals -7/4 x minus 5. Okay, so let's write an equation for each of these. So basically, I think the thing for each of these is really you just kind of have to decide, am I going to use point slope form or I'm going to use slope intercept form? That decision is really pretty easy. Have you been given a y-intercept? If so, use slope intercept form. If you've not been given a y-intercept, use point slope form. Okay, so that gray problem is the only one on which we are going to be using slope intercept form. Okay, so this one's really pretty straightforward. We plug, it's y equals mx plus b. We're going to plug in the slope for m, and we're going to plug in the y-intercept for b. And that's it. Okay. Point slope form is really, honestly, pretty easy too. The thing to remember here is that x values come first and y values come second in ordered pairs, and we want that to be a solution. Okay, so when you're writing with your y over on this side, you got to imagine, okay, imagine now I'm plugging in -4 for that y and I want it to be 0. Well, that would mean I need to write +4, right? Because if I plugged in the -4 plus 4 would be 0. I'm taking the opposite, okay? Then goes my slope, and then I do the exact same thing for x. So you're taking those opposite x and y values because, again, now just go back and double check. If I plug in -3 for x and -4 for y, do I get 0 equals 0? I do, so that's great. Okay. The problem I have on this next one is that I can kind of start the problem, right? I'm going to use this first point. I can technically use either. Okay, and I'm going to write y plus 5, and I'm going to write x minus 2. The problem here is that I don't have the slope. Okay. Easiest way to find slope is just calculate your change in y over your change in x, and a change is just subtraction. Okay, so it doesn't matter which way you subtract as long as you subtract the same way. Okay, so I'm going to come over here and I'm going to subtract my y values. Remember, those are my second ones, and I'm going to do -5 minus +5. The only thing I got to make sure of is that I do the exact same subtraction over on the other side. Okay, so I can't do 0 minus 2. I now have to do 2 minus 0. Okay, because I subtracted this direction. Okay, -5 minus 5 is -10. Divided by 2 is -5. Great, so my slope is -5. And I plug that right in there. Okay, so that's my slope. On the very last one, this one actually, I promise you it's a lot easier than it looks because I can still do the exact same thing that I did in that red problem up there. Okay, I'm writing my y plus 5, I'm writing my x minus 4, and now all I need is the slope. Well, I've been told that it's parallel to that particular line. Well, this is the slope of that line, and parallel lines have the exact same slope. So all this is really telling me, this is just a roundabout way of telling me that it goes through 4, -5, and has a slope of -7/4, which I'm just going to put right there. Okay? And that's it. Okay, it was really the same problem as the red problem, except instead of telling you the slope directly, it was kind of given to you a little bit indirectly. Okay? Take a few seconds, think of any last-minute questions you have. That was kind of a quick rundown of everything. I'm going to go over a few extra things that I think often confuse people. Okay, and that is going to be 3 total things, and then after that, I'm going to be all done. So if you got any last-minute questions, now's a good time to ask them. Okay, perpendicular lines. Okay. We just talked about parallel lines, but we didn't really talk at all about perpendicular lines. Perpendicular lines have what we call opposite reciprocal slopes. Okay, so if I know that I have a line with a slope of -3/2, and I want to know the slope of the perpendicular line, I've got to do 2 things. I've got to change it from either negative to positive or positive to negative, and I got to take my fraction and I got to flip it. Okay. So I'm going to change this to +2/3. Okay, I'll do a couple more just to kind of make sure we get the idea. If I have a slope of 3, a perpendicular line would be -1/3. If I have a slope of oh, let's go with 1/4, I would convert it to a slope of -4/1, which I would, of course, probably write as just -4. Okay? Um, and then the other thing I want to go over, so that's perpendicular slopes. So really, I'm going to actually circle back to this exact same problem, and let's do it one more time. Okay, so we're going to look at the green problem again, and we are going to we're going to get rid of the word parallel. We're going to change it to perpendicular. And now it's almost the exact same problem. Okay, so if I were doing this problem, I would still write y plus 5. I would still write x minus 4. Okay, the only thing that I would change is my slope. I know it's perpendicular to a slope that's -7/4. I take the opposite reciprocal, so I'm changing it from negative to positive, and I'm flipping my 7/4 to 4/7. So that'd be my answer for this perpendicular. Okay. And then the last thing I want to go over is horizontal and vertical lines. And actually, I'm going to go back to the graph for this. So if we look at two lines, and let's go here, okay, because that is the, oops, sorry about that. That is the point 3, 1. Okay, and we're going to look at two lines. We're going to look at a horizontal line that goes through that point, and we're going to look at a vertical line that goes through that point. Okay. And we want to know the equation of each. Okay. So the equation of the blue one, what you have to realize is basically both of these, it's not that they both have no slope exactly. Technically, the horizontal line, so the blue one, has a slope of 0/1 or just 0. Okay. And the green line has a slope of 1/0 or undefined, like it has an undefined slope. Okay. So, but in reality, if you've got a slope of either 0 or undefined, you don't want to use point slope or slope intercept form. Okay. So what you have to realize is on the blue line, our y values are never changing. It never goes up. Okay. So the only restriction on that line is that all of our y values be the same, and in that case, it's 1. Okay. So the entire equation of the line would be y equals 1. Okay. And then, there we go. Oh, sorry, it looks like the stream was cutting out. Hopefully it's coming back a little bit. We'll see. And then the green line, all of those, it's not moving left or right. So the x values are all the same. So the equation of that one would be x equals 3. Okay, so it seems slightly counterintuitive. It's not, but it seems a little bit that way. Horizontal, when you think of horizontal, you think of moving in the x direction, so you think it might be x equals, but no, the x values are changing. It's the y value that's not changing. Okay, so equations of all horizontal lines are going to look like y equals and a number. Equations of vertical lines are all going to be x equals a number. Okay. Answering those last second questions, Tali asked, do we need to know how to form equations with perpendicular, vertical, horizontal, and parallel lines? Oh, she said just need to. So pretty much, Talia, that these 1, 2, 3, 4, 5, if you include the yellow one that we went over, that's most of it. Okay, I guess I could ask you about horizontal or vertical too. So let's throw one of those in there. Let's say it went through the point 4, -5, and I told you that it was horizontal. Okay, you should be able to write an equation for that too. Okay, because you should be able to graph one of those, but we should also be able to write an equation too, I suppose. So if I told you it's horizontal, again, what we know is that means it's flat. That means its y value is never changing. It's never moving up or down. So that means every single y value is going to be equal to whatever the y value is on this point, which is -5. So our entire equation would be y equals -5. Okay. Hirsch asked, are we going to have problems where we specifically write it in point slope or slope intercept form, or can we decide which one we want to write? Yeah, I thought about that a lot, and in the end, I'm going to let you decide what you want to write, okay? I don't think it's super important which you pick as long as it's accurate. Yes, Lucy, perpendicular and parallel can definitely be on the test, so know that parallel is the same slope and know that perpendicular is opposite reciprocal. Again, though, all we're going to have for perpendicular and parallel is stuff like this, okay? So in reality, those are all going to be very, very similar to that problem that's up there in red, where you've been given a point and a slope, okay? But instead of being given that point very directly, you're just being given that information a little more indirectly. If you end up with any more questions, I should be in my room by about 7:45 tomorrow morning, so we got a little bit of time. And actually, you guys are not taking that. Block 1 is taking it tomorrow, but you're not taking it until you're 50 tomorrow. So you should have time to stop in during recess too. Talia actually just, I was about to log off, but Talia just asked a great question. How can you check your answers? Boy, there's a lot of different ways to do that. Honestly, the hardest ones to check are really these, the ones that I have up right now, the ones where you're writing an equation, because in the end, there's not a whole lot you can do. You either know how to write the equation or you don't. Although the one thing you can check is, like in our blue problem where we were calculating the slope, you could check it. You could check your math on calculating the slope again, and if the points were reasonable, you could potentially put those on a graph and check the slope by hand by just counting the rise over run. So that's not the worst idea in the world. For checking all of your graphing ones, there's not a ton you can do. I think what I would do is I would essentially try, if I could, there's a couple things I would do. One thing is I would always be checking that all my positive slopes go this way and all my negative slopes go this way for any problem that had a slope. That's the one thing I would do. The other thing I would do is you could basically like double check your solutions, if that makes sense. So like as an example, really quick, I'm just going to do one. If I got y equals 1/2 x plus 2. Let's say you made a mistake and you thought for some reason that your y-intercept wasn't positive 2, you thought it was negative 2. It's not negative 2. This is wrong. Don't do this. See me shaking my head? Don't do it. Okay, but let's say you did that and then you went up 1 over 2, up 1 over 2. Okay, what you at that point would basically need to do is pick one of those. I mean, your slope is right, okay, but the other thing you could do is you could check like this answer. You could be like, well, I didn't start there, so let me check it, and let me just make sure that one's right. Well, that solution would be 4, 0. If I plug 4 in for x, do I get 0 for y? I'm hoping we can tell that we definitely don't, okay? When we plug 4 in for x, we get 1/2 times 4 is 2, 2 plus 2 is 4, so this should be up here. Okay, so that's clearly not right. So that's one of the things you can do too. You know, I mean, I think that's probably the, yeah, that would be another way that you could check your answers. Ones that are in standard form that you haven't converted to slope-intercept form or something like that, honestly, those kind of check the same way. Make sure, that's one of the things you could check too. So let me throw that out there. If I were doing like 3x minus 2y equals 5. Okay, so let's say I did not convert this to slope-intercept form, which I wouldn't recommend because 5 doesn't divide by 2. One thing you could do, though, at the very end, like after you've made all your points, you could still convert it to slope-intercept form. I know like it sounds like I'm saying two different things, but I promise you I'm not. Okay, so like subtract 3x, okay, and you get negative 2y equals negative 3x plus 5, and then you divide everything by negative 2. And look, you're finding out now the reason why you probably didn't want to convert it to slope-intercept form in the first place, because it's going to be hard to make an accurate graph out of 3/2 x minus 5/2. I don't want to graph that, right? Because now I got to guess a little bit on my y-intercept. But your final solution should still have a slope of 3/2. It still should have this slope. And if you look at your graph, negative 5/2 is about negative 2.5. So it should, see, it should go through right about there. Okay, so that, like, if you did it by solutions, okay, just by finding x and y values, converting it to slope-intercept form just to check like might be an okay way of doing it, even if it's just for the slope part. Even if you're just saying, okay, let me at least make sure that this goes up 3 and over 2, okay? But there's inherent risks in checking that way too. What if you messed up positive and negative signs? The long answer is there are lots of ways to check your answer. I think the easiest way is pick a point on your graph, plug it in, see if it works. If you got time, pick 2 of them, plug them into your equation, and see if they work. That's kind of the easy way of doing things. You can always redo problems too, but I feel like that takes a significant amount of time. Okay. Wildcat USM, no idea who you are, but you asked how long is the test. Not particularly long, couple of each graphing type, and then a few equation rights. I forget exactly how many it is, but it shouldn't be a huge deal. Also a good question coming in last second here. If we get a half for one of our numbers, can we try to graph them or should we just redo it? Folks, I don't mind halves so much. Those are relatively easy to graph, at least pretty darn close to accurately, but as much as you can, seek to get whole numbers, okay? As much as you can, seek to get whole numbers. Obviously not for slope. Slope we'd love to be a fraction, okay? But otherwise, try to get whole numbers, mostly just for accuracy's sake. But if you got to use some halves in there, that's fine. Try to avoid anything other than halves, though, because do you really want to be figuring out, how big a third of a box is, how big a fifth of a box is, or something like that? That doesn't sound great at all, okay? Oh, that audio thing is apparently a thing. Well, looks like my stream has lost its health a little bit. So anyways, that's a good time for us to stop. So hopefully this came in clear enough. If you have questions, come see me during before school or during recess tomorrow. Block 1, you've got your test tomorrow in your 50. Block 2, you're the next day. We'll see you guys at school tomorrow.